Well, this is the last session of the RUG event, and we're going to talk about a very exciting subject about DBOM versus EBOM versus MBOM. So I'm Jamie Griffis. I know Taylor introduced me, and I'm the PLM director and a partner at Applied, and also a senior team center architect. A little bit about background about me. I've been doing Team Center for about 18 years, doing implementations, upgrades, data migrations, CAD integrations, all things related about Team Center. I'm also an active member on the Siemens community. I'm a community catalyst, and I go out and help people on the community board with questions about Team Center. So I've worked in direct for companies like Rocket Lab, and also supporting Rocket Lab as a consultant. Worked at Crane Aerospace, Robbins, and some other consulting companies. It's a little bit of background about me, but I'll jump into what we're here for today. So DBOM versus EBOM versus MBOM. So what are the differences, and what's the difference between a DBOM and an EBOM will be majority of this session. But a DBOM is the design BOM. It's the CAD BOM, the NX, SolidWorks, Solid Edge BOM. It's where you're going to do all your design with your design tools, construction, geometry. You want to do layout control and 3D space reservations and deformations of parts. So this is where you're going to explore concepts, rapid iterations, configurations, and doing alternates. EBOM, I have here as enterprise BOM, also known as engineering BOM, and will often be referred to as universal BOM at some places, master BOM. So these are all the buildable configurations of the BOM. This is not necessarily the 3D representation, but more of like 150% BOM. It's the release of the final product. This should consume your software, your electrical BOM, electronics, colored parts, documentation, and then non-geometric components like lubricant or packaging that you don't want to push into your CAD assemblies. MBOM, we're all aware what an MBOM is, manufacturing BOM. So these are parts to build the EBOM. This is will include parts that are not shipped, manufacturing parts like tooling and fixtures, raw material, anything that's manufacturing only processes. This is usually a more flattened structure, and it's reorganized, these sub-assemblies, based on how it needs to be built and not what the final product needs to be. Often we'll have plant-specific parts. So if you're building something in 2 different plants, you may have plant-specific tooling or raw material, and that stuff would be in your manufacturing BOM. And this is typically the BOM that we would want to push to your ERP or MES system. So what's the limitations of using a single DBOM, EBOM? So it forces compromise between multiple domains. So it's going to push all configurations and all parts, all non-geometric parts, all reference parts, all into a single BOM. So this slows the release cycle because we need to have a compromise between multiple groups and get approval of the structure of the BOM and make sure all parts that are needed are in one single BOM. And it also, the change impact is greater because of multiple domains that need to interact with the change in a single BOM instead of discrete BOMs. Benefits to separate the DBOM, EBOM, and MBOM. So we'll talk about the DBOM first, the design BOM. So typically what we're doing in engineering and design is building bottom up. This is going to be many levels deep because we're going to spread out the work across many design groups and have many people authoring this data. It allows for rapid evolution of the product. and there's limited to no concurrent editing in a design BOM. One person will have the assembly and have the checkout in NX and be making those design changes. It's going to hold the geometric definition of the part, the 3D representation of the part. It's also going to contain reference geometry that's important to the other pieces of the design. So you may need to bring in reference geometry based on interfaces or spatial limitations that you need to do for your design. And that's something you don't necessarily need or will move into your engineering BOM. So that's the position of the product, the XYZ. And you're really concerned about the physical context of all the surrounding parts of what you're building in that 3D space. EBOM, Enterprise BOM, Engineering BOM, Unified BOM. So this is the metadata that's defining the part. This is a separation. So the design is the physical 3D representation. The EBOM is a part, the metadata, the definition of the part. This will hold relations to other products, to other product defining and supporting data of that part, that EBOM. It defines parts and quantities, logical conditions for variance, but it's not so much there for spatial relations. It's typically built top down, and when you bring in a design and a DBOM and EBOM together, you can build bottom up on the DBOM side and top down on the EBOM side and keep a very tight relation between the two. It allows for flatter levels than the design, so you don't have to get as deep. You can flatten out your assemblies for your product. It also separates out the evolution of the part from the design. So you can revise independently your EBOM from your DBOM and allow for that iteration, that faster, rapid iteration on your design side than on your EBOM side. And this will be where you're going to define all the buildable configurations of your product definition of your EBOM to feed your MBOM or SBOM, BOPs, etc. So bringing these two together we're coordinating the product life cycle. So we're separating out the two BOMs, but we're going to keep a tight alignment in independent life cycles. This allows the revision independence between the two. So you can have the ability to revise independently the DBOM to make CAD related changes that shouldn't affect your bill of material or your purchased components or your ERP part EBOM revisions, because it's mostly holding metadata and quantity and configuration of the BOM, will often have less revision and iteration on them like a design BOM would. So it also allows for the structure independence. So this will let you organize each one of them differently, but keep that alignment and know that you're using all of those parts in both the DBOM and the EBOM. With Team Center, you'll have the accountability check and will automatically see when you're under consuming or over consuming components between the two BOMs. So one thing, thinking about this is, you're gonna, EBOM is for like the configuration and the, if you have a car, you may have a 2-door car, a 4-door car, you're gonna have those different configurations built in your EBOM, and in your DBOM, you're not gonna wanna necessarily have to configure your BOM in a structure that will spit out a bill of material give a two-door car versus a four-door car. All right, so DBOM, EBOM, so it's often also called design part alignment. It's a global relation between the design revision, DBOM, and the part revision, the EBOM, that identifies the 3D representation of the part. So on the design side, you're going to have your 3D model, your JT file, your drawings. That's going to be represented by your part, which will have documentation, metadata filled out on it. These have independent life cycles, and so one doesn't necessarily force a change in the other. With Teamcenter's design part alignment, there's going to be automated alignment between the design and the part, and that can be checked in workflows to validate that alignment. When you set up DBOM, EBOM, you have to think ahead and figure out how you're going to do your part alignment. So the design part cardinality. And so there's 5 ways this can be set up. So you can have parts only, no design. So this would be purchase parts. They would be you'd be using the same part in both of your DBOM, EBOMs. This would be non-geometric components like fluids, additives, packaging, sealant. The next one is design only with no parts. So this would be on the DBOM side only. So this would be reference geometry, reference assemblies, collector assemblies, anything that you need to build that isn't actually a part number that needs to be ordered would be a design only. The one part to one design is sort of self-explanatory. You know, you're going to have one part that is going to be aligned to one design, their one-to-one relation. And then we move into the many parts to one design. So you're going to have multiple parts, 2 or more parts. It has the same geometry, but different characteristics like color or material, stainless steel. And those would have different part numbers for order, but they're represented by just a single design on the CAD side and many parts on the EBOM side. And the last one is one part to many designs. So these are where you're going to have flexible or deformable parts. So you would have multiple CAD models to represent one part number. This would be like anything you need a route. So hose, tube, you're going to buy a length of tube. It's going to be one part number. But for CAD, you need to route it multiple different ways. So you would align multiple designs to a single part and one part number on the EBOM side. So this is just a representation of trying to show some of this cardinality as you split out your DBOM and EBOM. And so on the left, we have a DBOM, and it has multiple components in it, and they're aligned to the EBOM, and so the parts. So we'll see on the left, our first subassembly has 2 components, and it's only aligned and shows up as a single part on the right. That is probably a purchase part. So say you buy a pump and you have all the pieces in the model because you need to show something. You really only need to purchase that one part number. So on the EBOM side, you really don't need an exploded bill of material. We also have software on the right, and then we have some more parts on the left on this second subassembly. We have a part that's aligned, a design that's aligned, and it's reused. We have 2 COTS or standard parts, the 2 different representations of the design, feeding into one part on the EBOM side. And the final one is more of like a reference assembly on the left, the bottom assembly, with two components. And only one of those components is being used in the EBOM side, but it's one designed to many parts. So we have this flexibility of having these discrete different structures that can have different levels and arranged differently with different parts because we're separating out the DBOM versus the EBOM. Let's talk about the manufacturing bill of material for a moment. So it's the manufacturing design defining data. So this would be the tooling resources, any sort of tooling you need to use, fixtures, jigs, the raw material you're going to use to machine these parts, M states, manufacturing states. So you're going to rearrange the bill of material because you need to, engineering has the way they need it arranged, and manufacturing has a different way to arrange it. Maybe you have welding that you need to do, maybe you have machining that you need to do, and so those would be areas that you would make different assemblies and M states for that. You also have consumables that are just for manufacturing only representation. So if you have extra O-rings or other consumables that you need in just the manufacturing of that assembly, those would be on the MBOM side only. And then again, with the plant specific parts. So if you have multiple plants that are going to have different parts, different fixtures, different part numbers, you would also include those. Here's a representation of that same DBOM, EBOM, but moving it into an MBOM. And so as you see, we move across where we'll be consuming and reusing some of the components from the EBOM, and those will be represented in the purple colored dashed lines. And then we will have the manufacturing parts only and different levels of the assembly. So we're going to move around components out of different sub-assemblies based on those M states or manufacturing processes. And so with the tools in Team Center, with the DBOM, EBOM, there's an accountability check. And then with the EBOM, MBOM, there is also what's called Easy Plan, which does an accountability check between the EBOM and the MBOM. And so what you're doing is keeping all of these BOMs in Team Center related to each other, so you can have that full digital life cycle. And what Bill was talking about earlier with requirements feeding into this, you're getting that large digital thread all the way from requirements through design and engineering, manufacturing, and there's also build process that this is going to feed into, electronic work instructions, that whole thing in here. On the far right here, you'll notice I am showing some raw material and some tooling. So hopefully these visual differences in these icons help explain the different parts and components that we'd use in different bill of materials and why they're separate. So as I was talking about, keeping all of these BOMs in Team Center in one location that they're related, you can do the impact analysis with the ECR, ECN. You can pull that ECN and create an MCN, so you get that full change process as well in Team Center, and you keep that full link so when you're making a design change, how it's going to impact your engineering BOM, how it's going to impact your manufacturing BOM. And this, shifting the manufacturing BOM into Team Center is a paradigm shift for some companies, but we're not saying we don't we don't want this BOM to go out of Team Center. We do know we need to feed other systems like ERP or MES, but having it in Team Center and being the source of truth in Team Center and having all this data linked together for that impact of change is very powerful. So a few things I haven't covered today that are also very important to BOM would be options and variance, and we talked a little bit about variance, but that would be one reason why you would really want to decouple the DBOM and EBOM. Partitions. So partitions will allow us to have a recipe that we can apply to the BOM. And when we have these 3 BOMs, we can share those partitions across all 3. So we can share those recipes on how we want to see it. And so we could break it up into a functional breakdown, logical breakdown. It could be, different stages of the product. There's infinite ways to break it down with partitions. And then work sets. Also smart discovery we haven't talked about, but this is very powerful on how you would use and filter the BOM to be able to use in NX or even just active workspace to display it. We also have effectivity and multiple ways you can do effectivity, so unit-based or revision-based. But one new thing that we didn't cover, which is a much larger topic, is a paradigm shift of thinking about revision-based EBOM versus usage-based EBOM structures. So that's a very new functionality in Team Center and something that we'll have to touch on in another presentation.